Hey guys, welcome to Magoma and Mlemo Science Hub. Well, this is Mlemo, and guys, another thing, I just simply want to officially welcome you to grade 12. You guys, you made it. This is the last part of your journey, so you should give it your all, give it your best, guys. That's all I want to tell you. And again, congratulations, you made it to grade 12. So now let's just go into grade 12 physical science and see what is Zishan. Okay, guys. So the first topic we're going to look at is momentum and impulse. And right now we're going to take a look at momentum, and then later on later videos we're going to take a look at impulse, and then we'll see further on what we're going to do. So the first thing, I just simply want to remind you of the thing that you know about momentum, and you never knew that you know these things about momentum. So we're turning back to grade 10 and 11. So the first thing we're going to take a look at is we must remember what is a scalar. A scalar is a physical quantity that is magnitude only. It means it does not have direction. Example of a scalar is what? Energy and mass. You cannot say something is 5 kg east or 220 joules west. That does not make any sense. And then another one is a vector. A vector is a physical quantity that has both magnitude and direction. Examples include velocity, force, acceleration. We can say we say that something is 5 newtons to the right, 10 newtons to the left, something, and then another definition is mass. A mass of a body or an object is a quantity of matter in the body. Mass is a scalar. Mass is a scale. It means it does not have any direction, and mass is measured in kilograms, kg. Okay, and then another definition is velocity. Velocity is the rate of change in displacement. The rate of change in displacement is how the displacement changes. So the formula to calculate the velocity is change in displacement divided by change in time, or you can say the change in distance divided by the change in time. Velocity is a vector quantity measured in meters per second. It means velocity, it has both magnitude and direction. And then another one is acceleration. Acceleration is the rate of change in velocity. In symbol, you can say that acceleration is equal to the change in velocity over the change in time. Okay, or you can say the final velocity minus the initial velocity divided by the time. Acceleration is a vector quantity measured in meters per second squared. It means when they say it's a vector quantity, it means that acceleration, it must have a direction, not magnitude only. You must say something is 2 meters per second squared to the right, something like that. Okay, and then now we're going to grade 11. In grade 11 we learned about Newton's law. So now we're going to take a look at Newton's first and second law. The first law, not so much, okay, but we are in this chapter, we are simply going to take a look at Newton's second and third law. So we'll remind you on Newton's second law. Newton's second law says that when the net force acts on an object, the object will accelerate in the direction of the net force with an acceleration that is directly proportional to the net force and inversely proportional to the mass of an object. That's Newton's second law. And then take a look at Newton's third law. Newton's third law says that when object A exerts a force on object B will simultaneously exert an oppositely directed force of equal magnitude on object A. Okay. When I talk about Newton's third law, it's more like when we are punching a person. When I'm talking about physics, when you punch a person, you are punching that person maybe with 10 newtons. But what we do not know is that that person is also punching you back 10 newtons back to you. Their face is applying the same force or the same magnitude back to your fist. Okay, and then the last one is the law of conservation of energy. We learned this in grade 10. So we know that the law of conservation of energy states that the total energy of an isolated system remains constant. Okay, now I just have something, just want to see if you still remember this. We learned this in grade 11. the action reaction pairs. So here's just a check yourself. Number one, they say identify the action reaction pairs of forces present in each of the following situation. Number A, swimming across the pool. If you want to know the action reaction pairs, okay, it means that you're going to say the water to the person who's swimming, okay, or the water to the pool and the pool to the water, or the water to the person to the water. And then number B, the book rests on a table. It means that the table to the book to the table, or the table to the earth and the earth to the table. Number C, the soccer player kicks a ball. The ball to the soccer player to the ball, or the ball to the ground and the ground to the ball. Number D, a rocket accelerates through the space to the rocket, or the rocket to the space. Okay, that's the action reaction pairs. Right now going to go into momentum into details. You can think of momentum like a crash, like when two things collide, like the boom, like the something. That's how I can explain it. It's like the between two objects. Examples: when two cars crash, and sometimes one of the cars might lose certain parts of its body. When two cars crash, some cars become like, oh, the shape. But let's not talk about accidents. Some people might be offended. Okay, now definition and calculation of momentum. All objects have mass. When an object is moving, it has momentum. The momentum P of an object is the product of the mass and velocity of an object. It means that momentum is the product of the mass of the object and its velocity is traveling in. That's the formula to calculate momentum. It means momentum is the mass multiplied by the velocity. Okay, momentum is a vector quantity. It means it must always have magnitude and direction. Okay, and then here we're having a worked example. They say calculate the momentum of a 1300 kg rhino galloping east at 15 meters per second towards a approach. These people, some of us don't know what galloping means, but from reading the question, I simply know how the rhino is running fast towards a poacher. Even if they did not say this galloping nonsense, they say calculate the momentum for 1300 kg rhino going east at 50 meters per second towards the poacher. Sorry. Now we should check what do we have. We have the mass and the velocity. Now we should identify the direction of the velocity. They say that the rhino is going towards. It means that the velocity is positive. It's going towards, not backwards the poacher. It means that the velocity, it is a plus 15 meters per second. That's why they wrote the sign. Okay, now we want to calculate the momentum. Momentum is equal to the mass multiplied by the velocity. So we're going to say 1300 multiplied by positive 15, which is going to give us 19,500 kilometers per kilograms east. And then here we are having just another question. You can screenshot and do it, and if you want the memo, you can text me on WhatsApp. I'll leave the link to the group on the description code, and then on the next video going to look at collisions.